Hi, everyone. Hopefully you're having a great morning. I'm here to talk about the business use cases for Amazon machine learning, which is a pretty exciting product and part of the Amazon AI suite of products. The agenda for today, we'll talk about some of the smart applications that are developed using Amazon machine learning, and then we'll talk a bit about how you develop applications with Amazon ML and go through the flow of how you go through and create a machine learning model for use in smart applications. Then I'll go ahead and do a demo of that using a malware data set to kind of illustrate one of the examples for how machine learning is used to address business use cases. And then I'll talk briefly about how Amazon fits into other AWS AI services. Amazon ML is not the only AI service as part of the AWS portfolio, and I want to make sure that everyone understands how it fits in and how it can be used. And then we'll have some time for Q&A. So to start with, machine learning and smart applications, we have an AWS description of what they are, and in some ways, machine learning is a term that gets tossed around for a large number of technologies. The way we think about it in AWS is machine learning is any technology that automatically finds patterns in your data and uses them to make predictions or inferences based on new data points as they become available, which is key to smart applications, because if you take your data and you take your most recent data and you apply machine learning to it, you can have smart applications that are responsive to changes in the working environment of that application, whether it's changes in the user, changes in things like the weather, changes in the economic environment, and so on. And this is an extremely powerful set of technologies that can be used to leverage the data that you have in your business that is unique to you and your relationship with customers. So let's kind of jump in and look at one of the successful examples for how a company has used Amazon machine learning to do things that they couldn't otherwise do in the absence of that product. So BuildFax is an example of one of these companies, and the challenge that they faced is insurance companies, their customers, spend billions of dollars on roof losses annually. And this is something that, in order to get good estimations for things like roof age and condition estimates to feed into job costs, which are a source of the claims against the insurance companies, in order to get good estimations on them, they have to use the most accurate technologies that are possible. And the way BuildFax addresses that for their customers is they provide roof age and conditions estimates with the help of Amazon machine learning. If you see that there's a quote from Joe, who's the founder and chief technology officer for BuildFax, it basically allows BuildFax to democratize the product of building predictive models. In other words, it makes this predictive technology much, much easier to access, and it has built-in best practices, which allows customers, our customers, to put machine learning in places that they weren't otherwise able to. Very similarly, we have another customer in Upserve, and Bright Fulton is a great customer of ours. They've used it in a very, very unique area where restaurant owners are looking to use data in order to better serve their customers. The restaurant industry is a particularly important customer service industry, and in order to provide the best possible experience, they want to be able to use all of the data that they have in order to make sure that they have the right staffing levels, make sure that they have the right items on the menu, and so on. And Upserve uses Amazon machine learning and the restaurant's ticket data as well as other environmental factors such as things like, hey, how's the weather today? If it's rainy, people are less likely to go out. If there's a baseball game, people are likely to go to restaurants in the vicinity of the baseball park and so on. And they use all of this data in order to provide their customers with very accurate estimates on the number of customers and the items ordered with the help of Amazon machine learning, which allows their customers to have the right staffing level and to have the right ingredients available in order to make sure every customer leaves the restaurant satisfied. So there's also a few more examples that we throw out there. This is far from a comprehensive list of examples for the kind of thing that you can do with a easy-to-use machine learning system like Amazon machine learning. Examples that we've seen are fraud detection, where you can kind of look and say fraud or not based on the data that you have about the transaction, the data that you have about emails and reviews and so on. And this is a pretty common problem that we have within Amazon, of course, and we see our customers have as well. There's also personalization, which is if you have a set of data on a user and you want to recommend the best content for them, this is a categorical problem where you can say which category of content will work out best for the user. And this is another place where Amazon machine learning can be used. Targeted marketing is an example that we have our tutorial on. The tutorial example that we have is based on banking, where we take a lot of data on banking customers in order to determine whether the customer is in the income level that would allow them to be a good target for the offer or not. And this is the kind of thing that you could do. You could also do things like find out whether a customer is a good target for a cross-sell or an upsell opportunity and so on. It's something that you can use for content classification, for categorizing documents. I talked to a customer that has a workflow management system that has a large number of documents in it, and they wanted to use it as Amazon machine learning as part of their workflow to categorize the documents in real time so that they automatically get tagged with the right categories and they're able to use that information at further steps downstream in the workflow. Churn prediction is another very common example to try and figure out which customers will stop using the service. And not only that, but you can actually use that data in order to change the customer's experience. And I've talked to some gaming customers who use the real-time gaming data in order to decide whether to put an offer in front of those customers. If it looks like, based on the recent data, recent historical data in the last minute, in the last 30 minutes, in the last hour, they look at that data, they feed that into an Amazon machine learning model and determine whether the gamer is going to churn or not. And if they find out that the gamer is going to churn, they put an offer in front of them that could influence their likelihood of churning, so that they would basically be less likely to churn because of the offer that was put in front of them. Obviously, they could put the offer in front of everybody, but that comes at a great cost. So they actually have this optimization between making sure they're retaining customers and cost of the offer that they put in front of them. Customer support is another great example. Predictively routing customer emails, that kind of thing, by identifying the issue that they are likely to have based on the content of customer emails. Amazon machine learning, one of the hidden features of Amazon machine learning is that it's great at text processing. It has a really easy to use bag of words type of model for text processing, and that can be used to look at large amounts of unstructured text And you can do some pretty innovative things with it, even though it doesn't have the sophistication of natural language processing. There are a lot of problems, including this customer support, including spam email filtering, that actually work out pretty well, even without a sophisticated NLP model. So, I mean, the common question that I see from customers is, why not use business rules instead? It's what we've traditionally been doing. It's something that there's a lot of experience with. We can write SQL queries. We can actually have our analysts write SQL queries that say, hey, maybe for this particular offer, we can have a set of, we'll look at customers that shopped in 90 days and look at the category, and if they offered or if they took the offers on fidget spinners, we can offer them our new toy product and that kind of thing. And usually, traditionally, customers have been using business rules in order to do this type of, in order to address this type of problem. The trouble is, you actually end up with this large mess of business logic that you don't have a great understanding of how it works in totality as time progresses, because it gets more and more complicated as you build on top of it, as you address these edge cases. And the other problem is it's not as responsive. You can't just say, hey, you know what, find the customers that are most likely, based on the last weeks of data, to take this offer and target the offer to them. You actually have to explicitly pull out a set of business rules that say, these are the customers that ordered toys in 90 days and so on. By using machine learning to infer those business rules, you end up with something that's much more maintainable from a developer standpoint, that's much more agile from a business standpoint, because you can just automatically say, take the last week of data, take the last 3 weeks of data, and retrain your model over time in order to adequately address that problem. So let's kind of step through the flow that we would use in order to build smart applications with Amazon ML. It's pretty basic. You start out with data, you train a model based on that data, and as part of the training step, you separate the data into two sections, into the data that you're going to train the model with and the data that you're going to use to evaluate the model, the holdout set. So you evaluate and optimize the model based on that holdout set. And then once you have that, Amazon Machine Learning has a ready-to-go model. It's something that you can put into production right away. In fact, once you turn on the real-time endpoint, it can take up to 200 transactions per second with a typical latency of under 100 milliseconds. So it's something that's ready to go in production the very minute you finish training the model. So the steps that we go through: create a data source object, and the data source object we'll see in a little bit, but it basically will let you categorize the types of data. You explore and understand your data, and then transform the data as you need in order to train your model. So the first step, you specify the input. Amazon Machine Learning will take input from S3 or Redshift, and you can specify the bucket where the data is. The next, you specify the schema. There's 4 categories of data as far as Amazon Machine Learning is concerned. There's numeric data, there's categorical data, there's binary data, and there's text data. And by specifying the data type, you give Amazon Machine Learning an understanding of how it should treat that data and how it should analyze the data. Then you go through, identify the target variable that you're using as a prediction. And then you go through, review that data source. Also, for all of the steps that we take through, they're present not only in the AWS console, but we also have an API. It's built into the AWS SDK, which means that you can use Python or any of the other supported languages in the AWS SDK with the machine learning service. So the next step is to explore and understand your data. So Amazon Machine Learning provides insights into some of the distribution of your data, in this case, the target distribution of the income data set. It also provides that type of information for all of the categorical attributes. It tells you what the distribution is, what the most common category is for those attributes. You can look at sample records. You can look at how big the bins in these categorical data examples are as well. And then you go through and you train your model based on that data set. So it's actually pretty simple for the default case. You just click through, and as you keep clicking through, it just kicks off training. And you can specify a recipe. The recipe is some of the more advanced settings that you would use. It provides you with control over the binning on numeric variables. It also provides you with a way to do text processing on bag of words data. So you can go through. You can also evaluate and optimize it once the data is used to create a model. You can explore the model quality. It provides a graphical interface for what the distribution looks like on the evaluation set. And you can see what the distribution of the residuals are to kind of get an idea of how good it does against the average case as well as the outliers as well. For categorical models, it provides you with an F1 score that tells you what types of errors there are and which ones it did really well on. So in this case, you can see most of the time it got the prediction correctly. And then you can also fine-tune that model interpretation by, for instance, in binary models, you can change the threshold in order to suit your business rules. So if you have a different cost to a false positive error where the model incorrectly identified a case as positive as opposed to one where it incorrectly identified the case as negative, you can actually adjust the threshold in order to put your business costs into that calculation. Lastly, you use the model in order to do predictions. That's the whole idea of training this model. And there's two models for predictions. There's batch predictions, where you provide Amazon Machine Learning with a large amount of data, and it provides you back with predictions on all of those rows of data. Or you can do real-time predictions, as I talked about, where you can provide the data immediately and get feedback on that data within 100 milliseconds. So the cases where you really want to use batch predictions are where you have asynchronous requirements, where you want to have predictions on a large volume of data, where the applications are inherently batch. And you have a single click to generate batch predictions or a single API call as well. And it puts the data out into S3, which is in CSV files, which is a fairly common and understood format that you can use for further pre-processing. The second way is, of course, real-time predictions, where it does synchronous low latency predictions up to 200 TPS as we currently have it configured. It's best for interactive types of applications where you have individual data records and you want that feedback immediately. And because of that, you have an API. The API is the primary surface for interacting with real-time predictions, and you get the prediction in a JSON structure out. So let's go ahead and see a demo of this. It's not really, slideware is great and all that, but it actually makes sense to look at a demo and understand how you go through the flow. So I've actually gone through and done this example once before in order to avoid everyone waiting for it to train. As you can see, it only takes about 4 minutes to train the model, but still, 4 minutes of dead air time doesn't make any sense. So let's go ahead and select the S3 location where I have the data stored. And the data set that I'm using is actually from, let me click over there. The data set that I'm using is from the Australian Centre for Cybersecurity. They have a sample data set that's based on TCP dump files using log files in order to identify various types of attacks. As part of providing this data set, I actually stripped out the types of attacks to use Amazon machine learning for the binary prediction of, is this an attack or is this not an attack? It could be used to categorize the particular type of attack as well based on this data set. So let's go ahead and say UNSW-NB15 data, and then verify the data set. So as you see, it automatically determines the schema. I don't even need to specify all of the data types. I do specify that it has headers. As you can see, the sample field value 1 has the headers in it. So I'll go ahead and tell it that the data set has those headers. And you can see a sample data set. If you click on continue, it says you must pick a target, because we said this is something that is going to be used for training a machine learning model. And the label attribute is the thing that's being used in order to train the model. So let's go ahead and click on continue. This data contains an identifier which identifies a particular row. And the reason that you would actually want to specify an identifier is that when you actually look at the data set from batch predictions, you can use that data set from you can use that data set to actually correlate the prediction with the initial data that you provided. If you don't have a row identifier for that purpose, then you wouldn't be able to do that. You would want to do that in cases where you're more interested in the statistics of the output instead of each individual record. But in this case, we're interested in the individual records, so we're going to specify the identifier field. So we go through and review everything to make sure it looks good, and click on continue. And it goes ahead and starts creating a data source. In this case, we could use the default recommended training and evaluation settings. And if I did that, I would just click on review and we could go ahead and create an ML model for that. But I want to show you an example of how you can specify some custom parameters in order to make the model better. So we'll go ahead and click on continue. This is where you would provide a recipe in order to transform the data. In this case, we're just going to take the default recipe. We're going to use all of the data fields in order to generate the model, and we're not going to do any pre-processing on it. If we wanted to improve it further beyond the point that the default recipe provides, this is where we would be able to provide some of that expertise. Then we click through and we say, okay, yes, we're going to shuffle. We're going to leave the maximum model size, the number of data passes through it constant. We could actually say, hey, you know what? We want it to refine the model, continue to refine the model on that data, and we could have up to 100 data passes on that data set. We'll say we want to evaluate the data, but instead of saying we're going to split the data source sequentially, let's say that we actually want to randomize that data set. So between shuffling the data and taking a random 70% of the data set for training, we can be sure that even if the data, in this case, the log data is typically time ordered, we'll still get a good result out of the data. And then let's go ahead and review it. We are taking the default recipe, we see our advanced settings and so on, and we just click on create the model. And it'll go ahead and create the model. So I'm gonna kind of pull a cooking show moment here and say, well, this data the data source is being split up, and you can see that it's creating these two data sources, one for training, one for evaluation. It's creating the model, and we're going to go ahead and look at the completed ML model in order to move on and kind of understand how this works. So we see that for a completed model, you can actually enable real-time predictions right away, and you can say, you know, within about a minute, you'll see the real-time endpoint come up, and at that point, it's just ready to go. It can take real-time predictions. These REST data can be submitted to that endpoint, and you can get those predictions out right away. So let's kind of click back in and look at that, and it should be up and running pretty soon. The other thing that we can look at is we can look at the evaluation. So we see in this case that the evaluation is considered extremely good for machine learning applications. We have a 0.994 area under the curve, which is really quite good, especially given that we used a default recipe and didn't tweak the way that the data gets processed at all. And then you can see what the threshold looks like and where we pick the threshold. So 96% of the time it gets the answer correct, 4% are errors, and we've got a distribution of the false positives and false negatives. It also shows you precision and recall. And you can use these sliders in order to adjust the thing that is most important for your business, whether it's a false positive rate or a certain amount of accuracy or certain precision and recall and so on. And you can see that visually reflected in both the false positive and the false negative rate as well. So I think we should have the real-time endpoint up and running. Well, not quite yet, but let's go ahead and kind of set the context for where Amazon machine learning fits into the broader Amazon AI portfolio, and we'll switch back to the deck. So our objective here is really to make machine learning widespread. We want, in AWS, we really want the customer to be able to use machine learning in any place they have data for any problem that they really want to use it for. So, you know, if you want to do things in a very simple way and you want to leverage Amazon's expertise and Amazon's data for those problems, we actually have a high-level set of developer APIs in the form of Recognition, which does image processing, Poly, which does text-to-speech, Lex, which is a chatbot, and Amazon Kinesis Analytics, which actually will do anomaly detection on an incoming stream of data. We also, if you have a little more expertise and you want to leverage your expertise and your data, we have what I'm calling these developer platform components. And Amazon Machine Learning is a developer platform that is focused on enabling developers to answer data science problems. So if you are able to pose a problem and you're able to provide data in a machine learning problem, you're able to pose this machine learning problem and you're able to provide data in the form of CSV files, Amazon Machine Learning will let you generate a machine learning model based on that data. But in addition to that, we also have data scientist platform components which enable you to use your data science resources and your more technical resources in order to get a high level of machine learning results based on the data that you have and the expertise that you have. And we have Apache Spark MLlib in the Elastic EMR product. We also have MXNet and a deep learning Amazon Machine Amazon machine image that can be used in EC2 in order to solve truly hard machine learning problems. We also, all of this is based on a foundation of these low-level platform components, whether it's elastic MapReduce or EC2 in the form of high-performance CPU instances, GPU-based instances, as well as FPGA instances. And this is, of course, a work in progress. There's more to come in all of these areas. More AI and machine learning is done in AWS than anywhere else in the world, and we want to continue making that part of our promise and part of the value of the AWS platform.